Okay, so we're going to get started. Hey, everybody, this is Bill Graber.
And I'm Jake McAlpine.
And so Jake and I are going to take you through this duct leakage testing basics. We'll hit a few different topics and let's just jump right in. Um, I'm Bill Graber. I'm the marketing guy here at TEC and have been here for about 5 years now.
Yeah, and I'm Jake McAlpine. I do the lead technical support and training here at TEC. And I've been here for a little over 3 years now.
Yeah, and so we both bring some experiences from other roles. Jake, most notably in weatherization, both as a practitioner in the field as well as working at the state in Minnesota. So you can get some broad background from Jake on that, and he'll be taking us through most of the technical content today. Little housekeeping for me really quickly. If you registered and you entered your BPI number, give us about a week and we'll get that registered for your credits. If you're on this call, you're probably using our equipment, and just a quick reminder of all the different gear we make, both for building performance testing, historically with blower doors and duct blasters, and the gauges that go with them, but also more recently, really been doing more and more with HVAC, the digital True Flow and the DG8 and the products there. Our whole goal here is, if we're going to make a lot more building environments better, healthier, more comfortable, more energy efficient, durable, we've got to make it easier to do these tests and make it easier to get it right. And that's sort of what's driving us. So here's the agenda for today. We're going to talk a little bit about why do we test. Then we'll get into some resources for completing the testing, and Jake will take you through that. He's not going to give you full training in this webinar, but he'll touch on it and make sure you have resources for where to go for more details. Then we'll come back a little bit. I'll talk about how to maintain the equipment, and we'll talk a little bit about news and Q&A. So with that, Jake, let's just jump right in. Why do we test?
So there's a lot of reasons that we do these tests. Code compliance is a major driver of this. There's also a lot of different programs that require testing the ducts and having a certain standard there. But it can also be used to simply diagnose comfort issues. Ducts can be a major source of energy loss and comfort. And then kind of overall, any duct sealing we do lowers energy bills, which is, good for everyone.
Yeah, great.
So there's been a lot of change when it comes to the code portion of this. So I'm going to step through a couple of the most recent codes and just give a very broad overview of some of the things that we're looking at when we're doing tests for codes. So 2012 was kind of the point that I'm going to start with. Most states are at or beyond the 2012 code. There's a major thing that's laid out here, and that is the threshold for passing a test. So if you hit 4 CFM per 100 square feet of area that duct system's serving, if you're lower than that, it's considered a pass. That's a complete system, ducts and air handler. If you're in a situation where you're testing it rough-in, where the air handler isn't in place, you can still do these tests, test both sides of the system, but you'll have a different standard of 3 CFM per 100 square feet. There's also an exception here that says that if you're doing this total leakage test and the ducts and air handler are all within the thermal boundary, you don't have to do the test. So
Okay.
yeah, that's a big one. In 2015, a lot of that stuff stays the same. Major thing kind of for the testing side of things is that a written report's required. At this point, when this came out, we responded to this and used our auto test app and made a very nice report there, in part to help with this requirement. So then in 2018, largely again, like in 2015, not a lot changes regarding the testing side of it. There is a new exception though that says that tests aren't required for ducts that are serving ERV or HRV that's not connected to a central system. So a little clarification there. The big change really starts to come in the 2021 code. So first of all, we get definitions of what inside conditioned space means for the first time. I think there's about 10 of these here. There's a lot of detail there. One of them in particular says that duct leakage to the outside as a test can be used to determine if the ducts are actually inside or outside the thermal boundary. So to my understanding, that's the first time that the total duct leakage is actually named in code as a test. Another big change is that we lose that exception that was there in prior code that says you didn't have to do the test if everything was inside the thermal boundary of the house. And now we have this new standard of 8 CFM per 100 square feet for testing all ducts and air handlers when they're inside the thermal boundary. So that's a pretty big change in the 2021 code.
Yeah. Okay. So So even when they're all inside, you got to test them, and there's a metric there, and then duct leakage to outside specifically called out. So these are some changes. We're seeing it, right? We're seeing more and more people are
Yeah.
calling and doing the testing because of these changes and this new code being adopted in some of the states already.
Yeah.
So that's really helpful. You can see, Jake, nice history of sort of where, where has the code gone. I'm going to take just a brief sidestep here and talk a little bit about, so what's the code reflecting this stuff for? We see duct leakage to outside specifically being called out, and we want to highlight why is that such a big issue for controlling buildings performance. And we'll talk more about that. And then when you're testing inside, if you live in the upper Midwest or in the Northeast where a lot of ductwork is inside the envelope and has been, like it is in Minnesota, we know how bad ductwork causes so many comfort issues, but it's not an energy penalty. So now I'm going to dive in a little bit about duct leakage to outside, which is a major energy penalty and comfort issue. And so this is a case study that's out there. You can see this on the HVAC school. Brian Orr's organization, they put this out. Steve Rogers from our organization, along with Brian and Russ King and Jenny Garcia. You can't eat soup with a fork. This is a Miami case study that was looked at a few years ago. And it was a home comfort issue here where it just, the house was not maintaining its set point, and it's set to 72, but it's slipping to 80 degrees, and it has high relative humidity. What's going on here? Why are we not able to fix it? And we're going to find out, hey, the issue is you got duct leakage to outside. So in this case, looked at what was going on with the house. Maybe the equipment's undersized, which is a common thought, initial sort of intuitive. And so that was looked at through the manual J review. And on the left here is the equipment, and on the right is sort of what are the requirements of the home. And it's like, well, hey, this equipment actually is sized really well for both the sensible, the temperature in the blue, and then the latent, meaning dehumidification. It's actually sized very well. It's almost exactly at the right capacity. Looks pretty good. So if we have this kind of coverage, why are we still unable to keep up? This is just letting you know there's many different places you can go to calculate that. So the house is depressurizing, when the HVAC turned on, and this is sometimes used as a really quick way of checking out, do I have duct leakage in one duct more than the other? And in this case, because the return, it's almost all supply, it was very helpful in saying, wow, we do have a lot of leakage. And then through testing, it was confirmed, and some analysis done by Russ and Steve. Wow, we are increasing our infiltration by 280 CFM because we have leakage of 384 in that ductwork. And so we thought we were delivering with our 4-ton 1400, and that all wasn't getting back into the house. And then the real issue is because we were having that leakage in the ductwork to outside, we were also pulling in this air that's basically full of humidity and outside air through the envelope and adding to the load. And so, they went up into the attic looking for some major leaks and didn't find any. They said, oh, well, we must have some major leaks. Did not see things like this. And so what was going on? Well, the leaks were pervasive, small, leaks and cracks. And so we thought we had this. We had our equipment on the left that had this kind of capability, and the house was here. But because of that duct leakage to outside, what was really going on is we weren't delivering all of it. So this was the actual reduced capacity of what we were able to deliver because of that leakage. On the house side, because we were pulling in more air, it wasn't what we thought it was. It was pulling more inside air full of humidity. It's actually this. And so that extra infiltration adds to the load. And so we thought we had this, and we actually had that. That's the root cause of this major comfort issue. It's duct leakage to outside. And the load, this is just an analysis of the load. It's almost all this yellow hash mark. That's the latent load, meaning how much dehumidification, how humid is that air. Because it was in Miami, that was causing major comfort issues. What common solution to that is people say, hey, let's just throw in a bigger unit and move on. We don't have time to solve all that leaky ductwork. And when you put in a 5-ton, all you do is you push more air out that leak. And so you had this with the 4-ton, you end up with that with the 5-ton, meaning you still can't cover it. You just make the leaks bigger. You pull in more outside air, and it's just an endless loop. So the message here is when you have duct leakage to outside, and this is an example that's, a big leak to make the point, it causes major problems and we need to fix it. We need to diagnose it and we need to fix it. So hopefully you get a feel for why do we do this testing? Why is code changing? Jake, let's jump back now into more of the meat of this webinar, which is how do we do this testing, and take us through it.
Yeah. So when you do a duct test, whether it's a total duct leakage or leakage to the outside, you got some system components. So, in this image here, we're seeing you've got a fan, you've got rings on those fans. So I kind of think of those as like gears in a car. They're calibrated to work at certain leakages. So for very leaky things, you'll use the bigger hole or no ring at all. For tighter houses, you're going to use an increasingly smaller diameter hole in the ring. We got some flex duct that helps connect to the system. There's a flow conditioner when you're doing the depressurization test to help make sure we maintain accuracy while we're testing. And then you'll need a static pressure probe and a gauge. So those are your system components that you'll need to do the duct leakage test.
Okay, and now all that comes like in a duct blaster kit.
Yep. That all comes standard. Then in addition to that, to set up this test, you're going to need some way of sealing the registers. So there's a few different options for doing that. These are some of the common ones that we see, but just know that in addition to the gear, you're going to actually need some method of sealing up the intentional openings in the ducts so that we can measure the unintended leaks.
Okay.
So the way I approach duct leakage is I kind of try to break it down. It is more set up than a duct than a blower door test. That's kind of the background that I came from. So I like to break this down and kind of think about preparing the building itself for the test, stepping over to the duct system. Two main elements there are the ducts themselves and also the registers. And then lastly, I step down to actually setting up the equipment, and I break that kind of into two groups, connecting the fan and making sure that your gauge is set up properly so that you're ready to do your test.
Okay, yeah, that makes sense. 3 steps kind of at a high level. And in some ways, the analogy to blower doors helps for a newer person like me.
Yeah. So when we think about the building, step one, you need to turn off any combustion appliances. This applies to blower door. We also do this for duct blaster. We're using powerful fans in these sort of tests. Any of the combustion appliances in the house, you want to just be safe and make sure those are shut off and that you don't backdraft those.
Right.
In order to be accurate, you need to have your exhaust fans also shut off in the house. So anything that's, range hood, bath fan, even a whole house vacuum system, they're rare, but anything that's going to exhaust air from the house, you need to shut off because it's just going to add complexity to the test that we don't want to deal with. And then for this test in particular, you're going to want to shut the air handler off because we're going to be using our fan to pressurize that system. Once you've got that all set up, the other thing is that we're testing ducts within the house. We want to limit that house's impact on this test. So when we're doing a total duct leakage test, which is by far the most common test, you're going to want to open at least a door or a window to the outside to make sure that any of the natural stack and wind effect that is present in the house, that gets relieved. So those are your main setup points when you're looking at the building itself.
Yeah, okay, that makes a lot of sense.
So step two, the ducts. This gets a little bit more complicated, so I'm going to break this down into 3 steps. Number one, you're going to want to remove the filters. Now, in a centrally ducted system, you'll have a filter grill. Sometimes it's on the ceiling, sometimes it's on a wall. You might have some satellite ones that have multiple filters. You need to take all those out of the grills. And then if you have a central return system, make sure that you go to the filter slot and remove the filter there. So I've been asked this question a lot. Why do I have to take that filter out? So if we imagine a duct system, this is a supply side and return system with a filter slot in it. And we were to just take our gauge and a static pressure probe and go put it in the supply side. And we were to turn the fan on. And let's say that we turned it up to 25 pascals. We would be turning that up and seeing that 25 pascals where our probe is. The other side of the system that has a filter in between is actually going to see less airflow. That filter causes a restriction in airflow,
Right.
and it causes a drop in the pressure.
Makes
So
sense.
if I were to hook up the second channel, and put another probe in on the other side, I would actually read a lower pressure, something like this, where you could see 25 on one side and 19 on the other side. So you're gonna actually see that pressure drop from the fan. And this becomes relevant to us because if you were to take a leak, and if that leak was the exact same size and it was on the supply side, and you could somehow move or have the exact same leak on the return side and actually measured the flow through those. Next slide there.
Thanks, Jake.
What you'd see is that because you have less pressure on that return side because of the filter, you'd actually measure less flow through the exact same size hole. So any leaks downstream from where your fan is, if you leave filters in place, those are going to cause issues. You're actually going to measure an artificially low pressure for everything on that side. So we just wanted to dive into that to tell you exactly why you pull the filter out when you're doing these systems.
Jake, I want to take a very quick diversion. This is helpful to me because it's a nice summary. I've had these discussions myself many times, and I think this is the clearest. One of the things that I think confuses people, and similar to blower doors, but that's not how it actually operates. Just like in a blower door, we pressurize it to 50, but it's not going to see that pressure. And so this is more of just a way of us being able to do QA work, quality work, to say, how tight is that duct work? It's not trying to estimate the leakage during actual operation. It's trying to say, did we seal this well? Is that correct? Is that the right way to think about it?
Yeah, we're using a test pressure. We're all agreeing to test at 25 pascals.
Yeah.
We're looking for uniformity as how people test the systems, and so that we can compare, that we have, decent results that are portable, that we can take between houses, between systems.
Okay, thanks very, very much.
Yeah. So the next one then, once filters are out, is looking at the ducts themselves. Now there's two main areas here of things that you have to set up. Dampers, big issue here. So if you have a damper that is non-motorized, typically called a balancing damper, you can see it on the top there. These are dampers that the HVAC designers are putting in and using to basically set once so that they can make sure they get the right flow out of every register. Those are built-in parts of the ductwork. We leave those as is. Now, if we have, looks kind of similar, has a fairly similar design approach to it, but we put a motor on that and actually zone or damper off an entire portion and have multiple thermostats and have a zoned system. We want to make sure those are open. Those are actually going to act like a filter. If those are closed while you're doing your test, similar to that filter example, all the leaks downstream of them are going to be artificially measuring low because you're not going to get that uniform pressure. So zone dampers, you want those to be open. If you have a motorized damper that goes to the outside, there are some systems that have outside air and they'll have a motorized damper. That's actually a motorized damper you want to make sure it is closed. So that's how we deal with dampers that are inside the duct. Another big topic, becoming a bigger topic, is what do we do with other systems that are using the ducts? And this is oftentimes ventilation, but can be dehumidification. And what we have here is a slightly more complex area. But to boil it down, if you have a system that's connected and it's intermittent, you don't seal that up. If you have something that is designed to continuously be running, then you can seal that up. So the picture on the bottom there is showing, an ERV or an HRV that's installed in a system. You'll have a fresh air intake and an exhaust that exhausts the stale inside air out. Those are two that, if that's set up to be run continuously, you would want to seal those as well. But then also watch out for an additional pickup. Sometimes they'll have a pickup. In this case, they show one coming from a bathroom. That's essentially another register into your system. So you want to make sure that that's sealed. That all being said, your standard in your area, the program you're working for, or the code official in your area, if you have any questions on how they're treating that in your area, that's one area that I think you need to talk to your local folks to get the rules on the ground for you.
I'm just going to reiterate, Jake, because you've pounded this into me and it's really helped me. Think about these tests not as saying when it's operating, what's happening, but instead saying, I'm going to set this up so I can test for a quality sealing of these ducts. And that really helped me say, oh, I understand now why we're doing this. We're not trying to reflect how does it when it's operating. How am I going to set this up so I can get a good test of, yes, this ductwork is sealed well.
Yep, exactly. So next we move on to the registers. So you're going to need to do a temporary seal of all the registers. These are the intentional openings. When I think of comparing this to a blower door test, this is closing the exterior doors and windows on a house. Those are the things I want to close so I can test the unintended leaks. So registers are intentional openings. We'll seal those for the test so that when we build pressure in the ducts, the leaks we're measuring aren't coming through those known registers. It's coming through the leaks. So there's a lot of debate about how you seal these. I don't think we have any magic answer here. There's a lot of different, they can be on ceilings, they can be on walls, they can be on floors. You can have different surfaces. There's a lot of variability here. So what we did is we set up some of our equipment here that can measure incredibly accurately at very, very low flows. And we tested a bunch of scenarios. Yeah. So the kind of common ones are using some sort of duct mask to tape over the register, using a foam block to take the register out and put that into the boot, or to use some sort of reusable system that can clip on and make a temporary seal over the register. And what we saw when we had just a standard, floor with a register in it, screwed down, there's a little bit of variability between those types of sealing. Is this going to break the bank? This is, less than, a tenth to a half of a CFM. But when we have 10 or 15 or 20 registers in a house, this can start to add up, especially on a test that's close to passing. So the registers, matter, the technique, the surface has a much bigger impact. So in the middle there, we used a carpet pad and a very, kind of tight carpet. And 10 times, over 10 times leakier, with the exact same method. When you go up to a shag carpet, if you're in a house that has that special thing in it, it gets really, really bad. It's very difficult to seal tape to carpet. So the surface underneath the duct really matters as well. And when you take that and take different methods, you can have some really, really big leaks. So there's a lot of variability here. I think the takeaway that I took from, this study that we did is that the duct mask on a flat surface gets you the lowest. And once you step up to carpet on a floor, I think those foam blocks really are probably your best option, because they take the carpet out of the equation and they get right back to the boot and make a good seal on that boot. So, we just wanted to share that because we do get a ton of questions about how to tape. There's a lot more that we don't have time to go into here, but this is just hopefully some helpful information to guide folks.
Yeah, and I want to just add one thing. First of all, this is helpful. I like the way you summarize this because, again, I go back to we're trying to test the system, and this is one of the, we want to seal this so that we're not testing leaks through this carpeting and tape. Okay, so all of that's very helpful. And then we are looking at this because I would say of all of the discussions I have with people who are either installing or testing, sealing these registers is time consuming and problematic. And anytime they don't get good reading, this is where time can get burnt up. So this is something that we're looking at. We're trying to understand better and see if there's ways to improve this. So now we're up to the equipment. We've set up the house. We've looked at the ductwork. Take us through what we do next.
So when we connect the fan, we've got things start to split a little bit. If you're in a home that's got more than 3 returns in it, you really do need to connect to the air handler. The size of those returns are getting smaller and smaller. They can eventually cause a restriction to the fan. So our recommendation is that once you're over the 3 register mark, go to the air handler, take the service door off where the blower motor is. You're going to have to make some sort of connection point. In this picture here, people use cardboard. There's a few different ways to do that, but you want to make a good seal and get a nice connection at the air handler cabinet. If you're in a home that has 3 or less returns, those are much larger. They don't cause a restriction. You can go right to a return in that case and directly mount there. So in this case, that picture is showing the flex duct connecting and the duct mask being used to seal off the rest of the area around that register. So for pressurization tests, that's what these images show here. You have the flex duct that you can directly mount to, or you could take the fan, and the fan's light enough that the fan can actually be directly mounted in either of these situations. So you don't have to use the flex duct when you're doing a pressurization test.
And my understanding is that, we see more pressurization than depressurization when it comes to duct leakage testing.
Yeah, I would agree with that. Yeah. So next, with setting up the fan, when you're doing a depressurization test, so you've turned the fan and you're pulling air out of the ductwork, there's a few things they're different when you do this test. So there is a flex duct that we have connected. We need to use a flex duct because if we direct mount a fan, we don't know what's happening right upstream of that. So it's an uncontrolled environment. So in order to maintain accuracy, we say use the flex duct. When you're using the flex duct, we have this flow conditioner that we show in the image here that helps straighten out the air right before it hits the flow sensor in the fan. We have you use at least one ring. So the open fan setting pulls so much air. It's a very powerful fan. Makes it very turbulent. So we say at least use one ring. And then if you can get 4 feet of flex duct, that helps as well. So
straight flex.
Out, yeah,
I got it.
Yeah, as it comes into the fan. So when you're choosing to do depressurization, works just fine. You have 4 extra steps to kind of think about to make sure that you maintain your accuracy.
Yeah. And I've heard people use depressurization. Maybe you're going to touch on this, but because they prefer that, because then it pulls that tape or whatever you've put over the registers, kind of sucks them in as opposed to pushing against them. But you can see it's a little bit more problematic to do the setup of the fan itself.
Yeah. And to go back just one sec, when we went back to those tests that we did, we did see a very small difference, not a ton, difference between pressurization versus depressurization. So those numbers are a little bit smaller in a depressurization scenario. It was in the tenths or hundredths of CFM. So it wasn't huge.
When I was new and I did my first pressurization test at my home, it was just that I was not good at getting a quality I did not understand. And so I did blow a couple of them off, and I think you learn that lesson the hard way once and then you move on, but yeah. Okay. So that's sort of the pressure, depressure. Let's keep going.
So fan setup now it's the other half of the system is really the gauge. This is where a lot of the brains of the operation are happening. So simply put, your channel A is measuring your test pressure. So that's the pressure in the duct with reference to the house. And you can take that measurement at a number of different places. The 2 most common are at the first register, where you've got it sealed up. You can just put your probe through the tape, or you can drill a test port that's on the air handler. We say be about 5 feet away from the fan to avoid any unnecessary fluctuation from the fan, blowing air in there. So that's where you're going to measure your building pressure. And then your channel B is going to measure your fan pressure. And so what we're doing with channel B is we're taking the fan, the pressure from the flow sensor in the fan, and we're doing that with reference to where the fan is drawing air from, or the inlet side of the fan, or the easy thing to remember is the side that has the rings on it. So we're measuring a pressure differential from the flow sensor with respect to where the fan is drawing air from.
Pressure drop across that ring gives us flow. Okay.
So when we're doing a depressurization test and we've turned that fan around, if you take that same logic, we in a pressurization test, the rings are on the outside, we can see them. So we need 1 tube. So vast majority of the tests, we just need 1 tube on channel B. When you do a depressurization test, you've moved that flow sensor inside the flex duct. So now we need to add another tube to channel B. And there's a ring connection on the edge of the flex duct that you put the reference tap from channel B, so that we're maintaining that idea of measuring the flow from the sensor to where it's drawing air from. So That's just
Pressure
what,
pressure drop across that ring is still the way we get flow. So
yep,
we need to know upstream and downstream. That
yep.
makes sense. Yep.
So now that we've got the tubing set up, fan set up, the last thing we need to do is make sure that the gauge is interpreting that information and reporting it to you properly. So what we do with channel B is we've measured this pressure, but a fan pressure doesn't really mean anything to us. What we need is actually the flow. So what the gauge needs to know is what fan has made that pressure and what ring specifically on that fan has made that pressure. And those two pieces of information, the gauge then converts that fan pressure to the CFM that we're all used to using. So we can display that in two different ways. We can actually just use the flow. So channel B, if you look at the upper left corner of a DG1000, there's many different options of how to display your fan flow. In duct leakage testing, the flow at 25 option that we show here is going to calculate. If you can't reach 25 pascals, the gauge can actually take that pressure that you have on A and the flow that results from it and project it up to 25. If you are at 25, the flow function works just fine as well, and it gives you the flow at the exact pressure that you're seeing on channel A. So those are the two main options that folks use.
Yep.
A thing that I think really helps is the tubing assistant on the DG1000. From the home screen, you click on that, answer 4 questions about the type of test you're doing, and it will set up both the fan and the flow. You'll get a flow at 25. And really all you'll have to do at that point is tell the gauge what ring you have put on the fan for that house. So you get down to basically one input that you have to put in yourself. On top of that, it also, if you look at the image on the lower right there, it'll actually update the gauge to show you, based on the information you had, pressurization versus depressurization, exactly which tap connects or what tube goes to what location for each
So
tap.
it does all this and helps you figure out, hey, what tubes do I need to hook on? Okay. Great. I think now we're ready to say that's kind of a whole good discussion on pressurization versus depressurization. Now I think you're going to touch very quickly, get a kind of a high level, again, not trying to give training on total duct leakage and duct leakage to outside.
Yeah. So now that we're set up, we got 2 tests that we can do with this. We've got the total duct leakage test. Again, by far the most common test, uses the duct blaster to measure all the leaks in the ducts, regardless of where they are. Total duct leakage. There's another test that we mentioned. It's the duct leakage to outside. This one uses the duct blaster in conjunction with a blower door, and they work in tandem to cancel out the pressure on the inside, and it just measures the pressure or the leakage in a duct system that goes to the outside of the house. So 2 very different tests. The total duct leakage test, as we said, it's the total amount of leakage regardless of where it is in the house. So that's a total duct leakage test. And we kind of think back to how we set up here. We've prepared our building, we've prepared our duct system, and our registers are taken care of. We've got the duct blaster fan. We've decided pressurized versus depressurized. We've got our gauge set up. The last thing we really need to do is decide if we're going to do an automated test or a manual test. So as you can see in the image there, a manual test is you controlling the fan yourself, turning it to 25, taking a reading. An automated test actually uses an app to operate the test and generate a report for you. So you've got decisions and of how you do the test based on that. So for a manual test, what you're going to do is once everything's set up, we're going to manually turn the fan up until we get that duct system to 25 pascals. If you're pressurizing, it'll be positive 25. If you're depressurizing, it'll be negative 25. And you use the channel B is either going to display your at 25, flow at 25. If for some reason you don't have that set, we actually have old charts that we can get to you. If you got an older gauge and didn't have that functionality, couldn't get to 25, you can use those factors to update your flow. Once you're at 25, what we recommend is on channel A, there's a function on the DG1000 that changes how long the gauge averages, and change that to 10 seconds. And what that does is essentially you're at 25 pascals. This is going to sample for 10 seconds and average everything together and give you a better, more accurate answer.
Yeah.
After 10 seconds, you're going to see the flow pop up on channel B. You record that, you're done with the test. You can then,
Right.
unpack and return the house to the condition you found it in. So the difference then with an automated test is that we'll set everything up, and instead of manually cranking up the fan, it will actually go to your phone or tablet and launch the auto test app.
Yeah, this is a free app. I just, free app that's intended to work with our gear and make these reports.
Yep. So you'll create a project for the house. It'll fill in, geolocate and get all the information for the house. You select a duct test, and then there's a connect button. It'll see your DG1000, and it'll pair within the app itself. And then you just simply hit this run test or start test button, and the app will control the gauge. The fan will come up to 25. Once it gets to 25, it'll start sampling. It actually samples and takes more data than in a manual test. And then as soon as it's done, a report pops up. You're on a connected device, so you can send it instantly, to who you need. The big advantage here is you get better data, and it's a really nice report that you can put in a pass fail threshold. So just right on the report, it can tell you, did this thing pass or fail? You don't have to go figure out if you passed or not. Right away.
Yeah, makes that compliance part for the code, for the report and the pass fail a lot simpler.
Yep.
And as you say, right when your test is done, your report can be done as well.
Yep. So,
all right, now let's talk leakage to outside, Jake. We talked earlier, code actually now saying, hey, measure this. It doesn't mean it's adopted everywhere, but this is coming.
Yep. So duct leakage to the outside. Just really quick, what are we doing here? Why do we need two fans? What are we doing? So I actually really like this test. It's a cool test. At a high level, your blower door is set to 25 pascals, and it's going to push into the house. It's these yellow arrows here, and it's going to be pushing in the leaks of the ductwork. It's going to create a pressure. You're going to take your duct blaster fan, and you're going to turn that duct blaster up until you bring that pressure in the duct with reference to the house back to zero. And what that effectively does is it has an equal force pushing through a leak, the yellow or orange arrows from the blower door, and an equal pressure from the duct blaster. And when you have an equal pressure, it doesn't matter how big the hole is anymore. With no differential pressure across the hole, there's no flow. So it's this ingenious way of eliminating all the leaks that are inside the house. The blower door will push, the duct blaster won't measure because it can't get through. That changes once you get up to an attic or a crawl space where the blower door can't push back against the duct blaster. And now you have leakage out, and then you'll have flow through the fan, which we can then measure.
So if this attic is vented and this is outside the envelope, then we're measuring that leakage because the blower door is not pressurizing against it.
Yeah.
Yeah, this is helpful when you show these two arrows. It makes sense.
So
okay.
That's conceptually what it's doing. I'm going to go back to total duct leakage and just say how it's different, how the leakage to the outside is different than the total leakage test. So when we're preparing our building, obviously we're going to set up a blower door, which we didn't have before. Another big thing is that we need to pressurize the house. So before we were relieving the pressure in the house, now this changes. Now you're going to set up that house like you're doing a blower door. You're going to close all exterior doors and windows. Good news though, duct system, exact same. Setting up the duct blaster, exact same, pressurized versus depressurized. One key point here though, is however you set up your duct blaster, your blower door has to be in the same direction. So you're either both depressurizing or both pressurizing. That's a key
otherwise
factor.
These two arrows don't push against each other.
Exactly.
Yeah, makes sense, Jake.
Yeah. Yep. And then so when we're doing a manual version of the duct leakage outside, with the duct blaster and blower door both capped off, we're going to do a baseline on that blower door gauge and enter that in. So it's baseline adjusted. And then we're going to open up the fan for the blower door, and we're going to have that gauge cruise 25. We'll walk away from the blower door then and go to the duct blaster. The house is now cruising at 25. So even if there's wind, we're counting for that, and we're maintaining 25. We unseal the duct blaster. We're going to see a pressure in that ductwork from the blower door pushing into it.
Yep.
And you can now then either cruise or manually turn your duct blaster up until you bring that pressure back down to 0. Once you're at 0, this is similar to being at 25 when we're doing a total leakage test. You can switch over to a 10-second average, get a good reading, and then record the answer, the flow off of channel B, and then tear down.
And that's that 10-second average is your duct leakage to outside. Good sample of that because of this test.
Yep.
Makes a ton of sense. Jake, one of the things that I skipped over a little bit quickly, you're saying here's how the manual, but we now have an automated DLTO test in Autotest. And this is at the time we're presenting this on June 6th in 2024, it's scheduled to come out within the next later this month. So we're a little bit ahead of it, but be looking for it. That ability to do that cruise 0 can capture duct leakage to outside and have a report for that. You get on the same system, you could do a total duct leakage and get a report for that. So 2 reports now available directly from Autotest.
Yep. Yeah, and so we're throwing a lot at you here. So here's some QR codes you can come back to if you want a setup video that goes through the total and the leakage to the outside tests. You can use those. If you need Autotest, that's a QR code to the download or to our website. And then if you just need general information, there's a lot of stuff we can cover here. The manuals and documentation on our website there is in the lower right. Yeah.
And, when I've done these tests, having these videos up, hitting pause as you're going through it the first few times for total and duct leakage outside, these videos are very helpful for that. Fantastic. We've moved quickly, but I think we've covered a lot, and hopefully you're feeling like, okay, I do understand why these tests exist, why duct leakage to outside is so important. Even though it's not the most convenient thing to measure, it matters a lot. And so this just is something that is out there. And even when it's inside the envelope, we know that now there are some metrics out in the standard, and that's because there's a lot of comfort issues caused by that. And there's resources available to seal up ductwork that is maybe even in hard to access places when there's things like AeroSeal and other things out there. So I'm going to touch quickly on how do we maintain the equipment? How do we make sure? Because we get more questions on this as people are doing more and more testing. And so I'm going to look at the system real quick. It's, as Jake has made very clear, it's the fan and the gauge. This is the system that's helping you make these measurements. The gauges are out there. Our newer gauges are 4-year calibration intervals. The DG700, which a lot of people still have, and we still calibrate often, that has a 2-year. And so that's one of the differences, that you've got to keep these gauges maintained through either recalibrating and or a field check, depending on what your policies are. Why are these different? Because we collect data, and in these DG1000 product has now been out for about 6 years. And this was the first 4 years. It drifts at about half the rate of a DG700. It's shown in red, DG1000 in black. We just get, based on some updated designs, we get a lot more stable reading and less drift over time. So that's one of the benefits of the DG1000. The other question that comes up a lot as we're looking to maintain equipment is, what's the difference between a calibration at the factory and a field check that someone might do with their provider or as an agency in the field? A factory calibration says we're looking at it as we find it when you send it back to us. So as found, how is this gauge performing? And then we recalibrate it and we say, well, this had some drift. We take that drift back out against a reference standard so that you're back at this thing's reading essentially perfect. A field check, you're just comparing how's this gauge doing compared to the spec and I do that by monitoring against a recently calibrated gauge. I don't do anything to fix any errors. I just say, is it an acceptable amount of drift still? So that's at a high level. So when you send it back to us, we've got a Menzer reference source that we use. When you're doing it, you're comparing it to a recently calibrated gauge and pressurizing both to see that they read similar. This just shows you when we have as found and as left, we might find some errors and then we take it out. Whereas if you go out to our website for a field check, you'll see that we give you, either you have your own forms or we have some forms and an Excel spreadsheet you could use that will just say, is it an acceptable amount of difference between your reference gauge? All of this stuff I'm referring to, here's another QR code for you out on our website. under the menu calibration and repair. A lot of stuff here, equipment service form, and more details about how do you do all this work. One of the things that is also on that same page as you scroll down is field check documentation for both the blower door and the duct blaster, which we just talked about. We've made a small update very recently to the fan field check for a duct blaster, where we're encouraging you to, how do you check this thing to make sure it's going to work well? It's a visual inspection, making sure there's not damage. You should do this anytime you think the fan might have been damaged or annually. Just make sure that everything looks good. Then you inspect to make sure that the flow sensor is in the right position following the procedure. We used to say, hey, check to see that the sensor on a duct blaster isn't leaky like we do on a blower door, which we continue to do. On the duct blaster, we no longer recommend that. This is a brazed sensor. Even if you drop a fan, that is not something that's going to be damaged. And we've had people get false diagnostics that, oh, I might have a leaky sensor, when in fact, it's just a challenge of sealing the smaller sensing holes in the sensor. So that's been updated and we no longer do that. If you want to check the performance, we have an optional field calibration plate, and there's a procedure and the process is laid out on that same page. So that's a lot of information we've gone through, a lot of updates. And what we're trying to do is say the resources are out on our webpage. Jake and I are available as well to help you. I'm going to just highlight now on 3 quick news items that we're trying to remind everybody about, and then we'll open it up for Q&A. First is we're moving next month, July 2024. We are moving. And as you are looking at getting gauges back to us up until July 19th, you're going to send it to our current address. After that, you will be sending it to our new address, which is it's just down the road about 10 miles from where we are now. It's still in the Minneapolis area. And we moving to this new building because it's going to open us up and help us meet some of our goals and our mission of helping you guys all do better work out in the field. And so it's going to help us with more space as we are looking to assemble new products and then establish a TEC training center, really to help us do train the trainer events more and more on how to do these tests. The other big news that's out, maybe you've seen it, is we have a sleep mode on the DG1000. So this is quick on, quick off. A lot more there. You can see Jake's got a nice 2-minute summary of that right on our website if you want to look at that. But if you're using DG1000s, one of the biggest complaints we've had is it takes too long to start up. This solves that problem with just like your phone, you can put it into sleep mode with a single tap, then you tap the screen or hit the power button. You're on immediately, and it will last a long time in that mode. So that's something that you can use throughout your day. Jake mentioned this already, but both for duct testing now, for total duct leakage to outside, and then for your blower doors as well. This auto test, which both Bluetooth and Wi-Fi connects, a bunch of work has been put in over the last several years for us since we introduced Bluetooth in 2019 to make Bluetooth connection more and more straightforward and simple. And, that's the one that we're committed to. Works really well. And so that is also now available. These are the resources. I'm going to put them back up as we now open up for the Q&A. Okay, so Jake, I think maybe you have some of the QA in front of you. Maybe a lot of them look like they're answered. Can you take us through?
Yeah, I can do that. So a couple of good questions here. On the technical side, a question from Ken about is, we talked about the filter being a restriction that we take out when we do this test. What about a heat exchanger? You can add a coil to that, other things. The answer is, yeah, those will cause restrictions. It's a lot less. And it's also, it's a built-in part of the system. I kind of think of those similar to the balancing dampers. It's an intrinsic part of the system. And filters change a lot. Filters can get pulled out, they can get put in, they can get dirty. Those other things can get dirty too. But just the fact of the matter is, all the standards that talk about doing this duct test, they say, pull that filter out. That's the one thing we kind of can control. And it's almost more of an agreement. Like we agree to test at 25 to set it up the same way. And this is kind of part of that setup.
I think I agree with what you're saying too, is just pragmatically, filters are pretty easy to take out. So we do it. Those other things are a lot harder to address before your test. Some of the effects are still there, but it's way harder to, address that. And so we don't.
So then we got another good question from Devin, saying, hey, if you've got leakage to the outside, if you're doing the leakage to the outside test, how much does the sealing those registers work? Since I've got the blower door pushing it one way and the duct blast the other way, Steve had a good answer here. Is it theoretically possible? Yes. Practically, what happens is the size of those registers are so big compared to the volume of air moving down them, it makes it very difficult to maintain anything close to an even pressure along a run of ductwork. If you were doing blower doors, it'd be similar to having, windows or doors open and in a longer house, basically. It gets difficult. You get pressure drop from those big holes. So sealing them up makes that test a lot more feasible. Devin also had a follow-up question. Well, hey, do I have to worry about sealing as much? And the answer is probably not. You've now, if you've sealed, go back to that data we were showing from before, I mean, a tenth to a half of a CFM, in certain circumstances, you've made that big opening a very small leak that can easily be blocked by the pressure balancing.
Yeah, and I've gotten this question a few times too. We actually have, I'll make a note, Jake. We actually have a write-up of why you need to still seal these registers during a duct leakage to outside.
Yeah.
And part of it is also that, you now get two big numbers you're subtracting to try and get a small number estimation. And so uncertainties will really play against you.
Yeah.
And so it's just practically, when you think, it's a great question because you're thinking about it and you're thinking about it the right way, but the practicality is you're not going to get good repeatable readings for all the things you just said. And it sounds like Steve also wrote that up. But we have a document. I'll add it maybe in our next newsletter. We'll have a link specifically, but you can also find that. If I have a minute at the end, I'll show you where you can find that and other similar information on the website.
Okay. And then it looks like we had one more from Ralph, and it's a good question. It's certainly a deep dive question. But he asks, if you've got ducts that are in multiple outside zones, is there a way to ensure that you can get 25 pascals across them? And the answer is that's tough.
But you can check it. You can pressurize and check it, and that's what you should do.
Yeah,
is you got to check all these far end. I'm sorry, Jake. Yeah, I should let you.
No, the method that I've heard, that Gary talks about is you can take two readings. And this would be a scenario. So let's imagine a house that's got some attic ductwork, and it's also maybe got crawl space ductwork, and both the attic and crawl space are vented to the outside. You could go and put your probe in the supply, get an equal length of tubing, and put another probe in the return ductwork and use a little plastic T and tee those together, and then run that to your channel A. Essentially, this isn't perfect, but it's about as good as you can do in one of these hard scenarios. And you're mechanically averaging, if you keep those lengths of tube the same length, you're mechanically averaging those two pressures. That's a way to get a uniform pressure. What you're likely going to have is one of those duct trunk runs being a bit over 25 and one probably being a bit under 25, but on average they'll be 25. That's one technique, Ralph, that I've heard of that you can use to do that. The larger point that you make here is that, and this would be more for a deep dive into ducts, is that pressure, getting even pressure in a ductwork system is very different than it is in a building. Like we kind of mentioned before, the dimensions being long with very big holes in them is a lot different than a house which is relatively large with small holes in it. So pressure drop becomes an issue the further you go down a piece of ductwork, and it gets a lot worse if you have really leaky ductwork. I'm embarrassed to say that I have pretty leaky ductwork in my house because it's all buried and I can't get to it. But I can measure that in my own house, that I don't see a full 25 at the very end of one of the duct runs in my house. So there's a lot more we could say about that, I think. But in general, when you've got that hard situation, you can try to get a reading from each of the ductwork to get an average.
Yeah. Okay. Well,
and one important point to add to that, so as Jake alluded to, the leakier they are, the more likely that is to get a pressure that's not uniform.
Yeah.
And so typically, if we're doing this for code compliance, the code is going to keep the leakage small enough that you get a pretty uniform pressure on most duct systems. It's typically when you're getting over something around 200 CFM. If you're getting, 400 CFM, 800 CFM, now you start having problems keeping the pressure uniform in the ducts.
Yeah, it's
But
like too many windows open in your blower door test. You just can't. Yeah.
Yep.
Sorry, Steve. Yep. Okay. Hey, Jake, were there other questions that we haven't gotten to yet?
There was one more quick
Yes.
here. This is from Thomas, is there research done on the difference on sealing the face versus the face of the sealing registers only as opposed to sealing against the surface? Steve, I haven't read through that response. Do you want to just answer that one?
Yeah. So the answer, this is the kind of the age-old question. Should I seal just to the register itself or seal all the way across the sheetrock if it's a sealing register or a wall register? And the answer is a leak between the grill and the sheetrock is leaking air into the same place that you're trying to push the air. So it's really not a leak that we're concerned about. So if you're doing a duct leakage to outside test, you should get the same result either way. If you're doing a total duct leakage test, the results could be different. And so on a total duct leakage test, you may want to mask all the way to the sheetrock because there's another leak there, but it's really not a leak. It's leaking into the same space where you're trying to push the air anyway. So that's the thoughts on that.
Okay.
I want to ask Alvaro sent in Alvaro Nonoal sent in a question. What is the best way to seal a tier place? I don't know what a tier place is. If you can type a response to that, we'll come back around to that one.
Yeah, and while we're looking, Jake, maybe there's other questions that have come up. Otherwise, I think this whole topic around sealing, you saw Jake share some preliminary results. That's where these questions are coming from. But we'll share more of this at upcoming conferences and on another upcoming training webinar in the future, where we'll talk more about all of the things we're testing and get more of your guys' feedback. This area of, there's a lot of questions out there. How can I get this faster, more efficient, more consistent, improve it? That this is just a part of this whole testing that we need to make easier. And so there does not appear to be any magic bullet here, but I do think there can be some testing that will incrementally help us all look at the situation and the kind of installs we have and know what's the best approach. Oh, on this one, I'm going to be using my foam. On this one, I'm going to be using tape. On this one, I can maybe use like a vent cap system or something that's not going to consume so much material and save me some money. There's all of them have their place, but we're going to be able to give better guidance on that.
Bill, just really quick in the last minute, Thomas had a question about, are ducts inside the thermal boundary are considered inside the thermal boundary if they're not actually in conditioned space, like in an encapsulated attic? That is a great question for the 2021 code. That those 10 things that define what I like that part of that change in the 2021 code is they give you something to actually chew on there, Thomas, that can answer that specific question. So it's going to be site specific, but I think code's moving in that direction to give you guys more guidance. And then really quick, Jess had a question about finding crimped ductwork. In the seconds we have left, which isn't enough, I'd say that you could probably look for pressure increase. So maybe just a manometer could help in that scenario. But if you've got more specifics, maybe shoot us an email and we can answer that in more detail.
I read that one as well. Just look for large differences in the static pressure if you are able to put holes in multiple locations of the duct system. If you see a big drop in the static pressure, that's an indication that something might be blocked.
Yep.
Okay, we're basically out of time. The one thing I said I would show was I came over to this support on our website and I just typed in a search, duct leakage to outside, and what came up is, do I need to temporarily seal the registers and grills? And so here's the answer to that question. It's a PDF that you can download. Again, we'll create a link later. I'm just trying to encourage, if you're still on, this is a great resource. If you come over to support, and then you can just type in whatever you're looking for or navigate via these menus. Okay, thanks a lot for joining. Steve or Jake, was there any other one that you think while we have it, I can see some people are hanging on, maybe they're waiting for their question to be answered, or did we get to them? All right.
We got to them. Yep.
All right, thanks again. There will be a recording of this available soon. If you typed in your BPI number, credits will be awarded within about the next week or so. Okay, thanks again for joining.